Okay, so last section we're going to look at is 4.3, and this is going to be on solving equations. So eventually, you're going to be able to solve an equation like that. Okay, that's a rational equation. So all the equations that we're going to look at, we're going to do most of them algebraically. We might do an inequality graphically, but we're going to focus mostly on the algebra stuff. Because doing something graphically, it's going to be kind of like what you've done before, finding intersects or things like that. But algebraically, we haven't really talked about how to do that yet. So for the first example we're going to do, you need this formula. Distance equals rate times time. Okay, if you take physics, sometimes you see distance as v or velocity or something like that, but we just use the letters that I think make the most sense. D for distance, R for rate, T for time. Okay, so in this problem, it says Sue drove 30 miles to a train station, got on a train, and then completed her trip from there. In all, she traveled 120 miles. We don't know how fast the car was going or how fast the train was going, but we're going to assume that the speed of the car and the trains were constant. Okay, the train didn't go faster and slower. Once the train got moving, it just stayed at the same speed. And once she was driving in the car, she set cruise control, no traffic, just same speed the whole time. Otherwise, if the speed is changing, that complicates things a lot. So the average rate of the train is 20 miles an hour faster than the average rate of the car. So we don't know how fast either one of them is going. We just know that on average, the train is 20 faster than the car. So they want us to find an equation for the time it takes to complete the trip. And now once I scroll down, it's going to give you the next piece of information. We could find the time it takes as a function of how fast your car is going or how fast the train is going. I only need to know one of them. Because once you tell me one of them, like if you say the car is going 50, I know the train's going 70. Right? But I only need to know one of them. So we're going to do it in terms of the car. X, we're going to pick a variable, we'll call it x, and x will be the speed of the car. It could also be the speed of the train, but we're not doing it that way. Okay, so first thing we got to just kind of think about is how many different modes of transportation is she taking? Yeah. Two. And she's going to spend time on each one of them. So the total time is going to equal what? I'm not looking for any numbers or anything specific here, but just kind of the general concept. The total time for this trip is this and this. Yeah.
The time spent in the car plus the time spent in the train.
So the time in the car plus time on train. Okay, now we need to figure these out. So we're going to write time as a function of x. So I'm calling my equation t of x, and x is the speed of the car. So let's take our formula, just kind of off to the side. Can someone tell me how you would take distance equals rate times time and solve it for time? Chris?
Do you want radius divided by distance? No.
Anyone else? Tell me, anyone else have a thought? How do you get t by itself in that equation? Brandon?
You divide by x to get t by itself. Oh wait, never mind. I was looking at that wrong. I don't know.
Sam?
Divide by r.
Divide by r. Yeah. D divided by r gives you t. So now let's figure out the time in the car. So to figure out the time she spends in the car, I need to know two things about the car. How far the car went, and the rate of the car. Okay. So how far did the car go? Yeah.
120 miles. Yeah.
No, not 120.
Oh, the car or?
How far? 30. Yeah, the car went 30.
I thought you meant total.
So the car is 30, and now I need the rate of speed of the car. Distance divided by rate. How fast is the car going? Emily?
3 miles per hour less than train.
Okay, do we have a way to, did they tell us how we have to represent that? But you are correct. Anyone else have a thought, Eric?
X.
X. X is the speed of the car. Now, let's get the time that we spend on the train. Okay? So to get the time on the train, I need to do distance divided by rate again. What's the distance that the train travels? They don't give us this, but we have enough information to reason it out. Yeah.
90 miles.
Yep. The train travels 90 miles divided by the speed of the train. What's the speed of the train? Now we're going to kind of use the fact Emily said. Yep.
X plus 20.
X plus 20. There's your equation for the time it would take to complete this trip. So you tell me how fast the car is going. If it's going 60 miles an hour, I'll fill in 60 for X. That'll give me the time in the car, time on the train, then I'll add them up. Okay, we're going to use that in a minute, but any questions on how we got it? Okay, so we found an algebraic expression right there. All right, so now I want to take the formula we just found, and I want to find all the stuff we normally would. Let's do asymptotes, zeros, the EBM, okay, all that good stuff. Now, remember, to find an EBM and to do some other things, it's going to be helpful to have this together as one fraction. So this is fine for now. In fact, this is better for some stuff. But I also want a version of it combined. How do you find a common denominator when you have two fractions? And I think we did this yesterday. Yeah.
Multiply like the denominator on the left by the denominator on the right.
So your denominator on the left is x, the one on the right is x plus 20. Common denominator is x times x plus 20. Now, Caleb, what is the denominator on the left missing so that it has the common denominator?
20 plus 20.
More than that. It's missing more. Like if I just throw a plus 20 on this, like that, is that the same as the common denominator now?
No.
No. So anyone help him out? What else is it missing? Yeah?
The x. So wouldn't it be x plus 20? Or it's missing x plus 20.
It's missing the x plus 20. It's missing this entire thing. We've got this. We don't have the x plus 20. So what am I going to have to do in the top and the bottom here? Eric?
On the first one, you gotta multiply by x plus 20.
Yep. Multiply by x plus 20. X plus 20. Now, we'll do that. Well, we could do it right now. 30x plus 600. And what is my second denominator missing to make it the common denominator? Nikara?
Times x.
Yeah, it's missing the times x part. So let's just put in a times x and a times x. Now the bottom we already have top becomes 90x. Okay, any questions on that? Now, what I want to do, so I don't get confused, I just kind of want to move this off like that, so I can see the original problem again a little easier. I won't get rid of it, but I just kind of want to focus on what was in the box. All right. We got some like terms in the top. Emily, what's 30x plus 90x? Yep. 120x plus 600. And Brandon, if I distribute the x in the bottom, what do I get?
X squared plus 20x.
Yep. Okay. That's the same equation. Now I'm just set up to do everything. I got the combined version. I got the separate fraction version. I can figure out anything you want pretty easily now. Okay, let's start with the asymptotes. Asymptotes, it's a lot easier to go back to the original, because to find verticals, you need to have the bottom factored. And in the original, it already is. So what are the two values for x that would cause me to divide by 0? Eric?
0 and negative 20.
Yep. I'm not saying negative 20 makes sense in this word problem, because that'd be negative 20 miles an hour. That doesn't make sense. But they just said to find all this stuff, so I'm just going to find it. Okay, let's do the zeros. So remember, a 0 or a root is a number you plug in for x and get 0 for what? Y. So it's basically like you're going to set this equation equal to 0. And it's a lot easier to use the combined one this time. All right, so zeros. What's the only way that a fraction can ever equal 0? Yep. That's vertical asymptotes when the bottom is 0. But we're close. Yep. The top is 0. So set the top equal to 0 and see what you get. 120x plus 600. Bring the 600 to the other side. And what's 600 divided by 120? Yeah, negative 5. Okay. So if you plug in negative 5 for x, you will get 0 for y. Again, does it make sense in terms of the speed? No. But I found it. So that's my 0. My EBM. So EBM. Makes more sense here to go to the combined one again. What's going to be in the top of my EBM fraction?
The number, like, at the end.
Well, before we even reduce it, what do we start with in the top?
120x.
120x. And in the bottom?
X squared.
X squared. And now what does that reduce to?
120 over x.
Yep. 120 over x. There's your EBM. Now we can use the EBM to find the horizontal asymptote. Tell me what happens to the EBM as x approaches infinity. What happens to my EBM?
It's closer and closer to 0.
It approaches 0. Remember, horizontal is always y equals. So do I have everything? Asymptotes, zeros, EBM. I just haven't done it on the calculator yet. Now, to me, complete graph, that's a little bit vague. What do you mean? Do you want a complete graph of this actual algebra equation, or a complete graph of this equation in the context of the word problem, which would mean I wouldn't even look at negatives. I'm going to look at it as just a complete graph of the word problem. All right. So that means can't go any slower than 0. Technically, there is no maximum speed. And remember, y is my time. Could I have negative 10 for time? No. What's the longest that this trip could take? Well, if you only drive 0.5 miles an hour, it's going to take a long time. So I don't know. So let's just put the max time at 10 hours. Okay, hit graph. Did I type the equation in yet? It's always important. You can type it in as the combined one or the original. I'm going to do the combined one. I think it's less typing. 120x plus 600 divided by x squared plus 20x. Okay, let's say graph. So what you're looking at is a graph of the time. As we head to the right, what's happening to our speed? Remember, that's a graph of time. So I wanted to know, remember, x-axis is speed, and as you head to the right, your speed is what?
Increasing.
Is increasing, so the time it takes to do the trip is decreasing. As you go slower and slower and slower, look what happens to your time. It starts taking a very long time to finish this trip. Okay, so there's all the important stuff they wanted. Now it says Sue has 2 hours to do this trip. How would I figure out, using a calculator, how fast she has to drive to do this trip in 2 hours? And again, this is the kind of thing we've done before. Yep.
You graph line at 2.
Yep. I'm going to put a line at 2. All right. And now what?
The intercept.
Find. Yeah. Find the intercept. So second calc intersect. First curve, second curve. They only cross in one spot, so it's not that important. 46.46 miles per hour. Okay, so that's how you do it graphically. Any question on that? Okay, now I want to do it algebraically. So that's t of x. No, sorry, I don't know that. My time is 2. I'm solving for 46.46. So my time is 2. And now just write down the rest of your equation. 2 equals, copy that down. We could use the original if we wanted, but I think it's going to make more sense to use the combined one. So I can't remember what was in the top. 120x plus 600. Can somebody remind me what was in the bottom?
X squared plus 20x.
X squared plus 20x. Okay, so first step, I don't like having the fraction. Let's multiply each side by the denominator. X squared plus 20x. Cancels that all out. Now do it over here. X squared plus 20x. Just remember it's distributive. 2x squared plus 40x. Equals, and on the right, 120x plus 600. Now, if you look at that, we don't have any fractions left. What kind of equation is that, basically? Focusing on the highest exponent. Yeah, it's a quadratic. So when we want to solve a quadratic, what do we always get it equal to? Yeah.
0.
Yeah, let's get it equal to 0. So we're going to have 2x squared. I'm going to minus 120x and minus the 600. 40 minus 120 is negative 80. Now, there's something I could do to this quadratic to make all the numbers a little smaller. What could I do there? Yeah.
Factor?
Yeah, factor or divide everything by 2. Yeah. I mean, it doesn't make them that much smaller, but a little bit. Now, unfortunately, you're not going to find two numbers that multiply to give you 300 and subtract to give you 40. I mean, you can do 30 and 10, and 30 times 10 is 300, but you have to subtract them, not add them. So this doesn't factor nicely. And the other way I know it doesn't factor nicely is I already know the answer. It's not a nice number. So how would you have to solve this if It doesn't factor. Yeah.
The quadratic equation.
Yep. So negative b plus or minus the square root b squared minus 4 times a times c all over 2a. I'll simplify what I can, and then we're going to need a calculator. What's 4 times 1 times negative 300?
1200.
4 times 1 times negative 300?
Negative 1200.
And what's 1600 minus negative 1200?
2800.
2800. Hey, I'm not going to do any more work to simplify. I'm just going to type that in on the calculator. So we've got, so it looks like we have 2 answers, right? Do you think she could drive 2 different speeds and finish the trip in 2 hours? Like if I said Boston's 50 miles away and there's no traffic, there's one speed you could drive at to get there in 2 hours, 25 miles an hour. Well, let's see what happens then. So we got 40 plus square root of 2800 divided by 2. 46.46 miles an hour. It's exactly what I got doing the graph. So that answer's the same. What do you think is going to happen when I do the other one? 40 minus the square root of 2800 divided by 2.
You're going to get a negative.
I'm going to get a negative, so I'm not even going to bother.
Just drive in reverse.
Yeah, you can go in reverse. So if you do the minus, you're going to get a negative speed. And technically, the negative is an answer to this equation. But it's not an answer to the equation in the context of a word problem because you can't go negative speed. Right? So the 2 answers, or the 1 answer here, got in 2 different ways, 46.46 miles per hour. So we got to be careful though, because what we did in this problem in the very first step is we multiplied both sides by a letter. Right? Notice when we did that, we got an extra answer. Right? We got this answer. We got this negative, which we didn't want. Well, whenever you multiply both sides by a variable, you can create an extra answer to the problem that shouldn't be there. Okay? That's called an extraneous solution. It's not because you did something wrong. It's just because that's what happens when you multiply both sides of an equation by a variable. So what you have to do is if you multiply both sides by a variable, that's okay, but check your answer. Make sure that the solutions that you get actually work. And I'm going to show you a simple example of an extraneous solution with a very simple equation. If I solve that equation that I just wrote, what do I get for x?
Negative 2.
Negative 2. Does anybody disagree with negative 2? Is there any other answer to that equation? No. Now, I'm going to take that same equation, but I'm going to multiply everything by x. Watch what happens. X squared plus 2x equals 0 times x is still 0. Does everyone agree that I correctly multiplied each term by x? So I did the same thing on both sides, right? You're always taught if you do the same thing on both sides of an equation, it's okay. So I did. I did the same thing on both sides of the equation. Now, I'm going to write the left-hand side like this. And ask you 2 questions. What value could you plug in for x to make x plus 2 equal to 0?
Negative 2.
It's exactly the same answer I had up above. What value could you plug in for x to make the first factor 0?
0.
0. Is 0 an answer to the first equation? No. So even though I did the same thing on both sides, multiplied everything by a letter, by doing that, I created an extra answer that was a solution to this new problem. But it wasn't a solution to my original problem. So what does that mean? This solution is extraneous. How would you know that? Check it. Just like you would in Algebra 1. Take your answer, plug it back in, and see if it works. Okay? This only happens for what we're doing if you multiply by a letter. Okay? So now we're at the example I showed you guys at the beginning of class. We're going to try and solve this equation. But the first thing we're going to do when we solve it is we're going to try to get rid of the fractions. I don't even want to have a common denominator. I want to have no denominator. So we're going to multiply each term by the LCD. So imagine I had something like this. X over 3 plus 1 over 4 equals 5 over 3 times 4. Look at all my denominators in that problem I just wrote. How many different factors are in my denominators? All 3 of them. The first one, the second one, and the third one. How many different factors do I have? About Caleb?
It's like 3 or 4.
Okay, go ahead and name all my factors.
1 and 3.
Well, 1's a factor really of everything, but there's no 1 in the bottom.
Oh,
So,
it's
2 factors, what are they?
2. Or like 2 or 4.
So 4, I agree. 4 is a factor. So we got that one. And what else?
3.
3. 3 and 4 are the only 2 factors. Yeah, the 3 is used twice and the 4 is used twice, but that's still the same number. So we only had 2 factors. If we multiply every fraction by those factors, okay, watch what happens. Let's multiply by 3 times 4, multiply by 3 times 4, multiply by 3 times 4. So I'm really multiplying everything by 3 times 4. Yes, I know I could write 12, but just do it this way, trust me. When you do that, what cancels in the first fraction? The 3's. Gone, gone. What cancels in the second fraction? The 4's. Gone, gone. What cancels in the third fraction?
3 and 4.
3 and 4, 3 and 4. So now all you're left with is 4 times x plus 1 times 3 equals 5. To me, that's an easier equation to solve than the original one, because I don't have any fractions. We're going to do the exact same thing down below. No difference at all. Okay. So what we want to hope is that the denominator on the right-hand side factors nicely. Okay. And by nicely, I mean it factors using the 2 denominators we already have. How does x squared minus 4x plus 3 factor?
X minus 1 and x minus 3.
It does. It does factor as x minus 1, x minus 3, and that will happen on the test too. If it didn't, this would be a little more complicated, but it does. Okay. So now I'm going to ask the same question I did before. How many different factors do I have in the denominators?
2.
2. What are they?
X minus 1, x minus 3.
X minus 1, x minus 3. Multiply everything by x minus 1, x minus 3. So x minus 1, x minus 3. X minus 1, x minus 3. X minus 1, x minus 3. When I do that, what happens in the first fraction?
X minus 1 cancels.
X minus 1 cancels. What happens in the second fraction?
Cancel x minus 3.
X minus 3 cancels. What happens in the third fraction?
Whole bottom cancels.
The whole bottom cancels out. So all we're left with on the right-hand side is, remember this is gone, 2. Now the left-hand side, you got a little bit of distributive property to deal with. You got 2x times x minus 3. What's 2x times x? 2x
Squared.
squared, and 2x times negative 3. Yep. This is the part where people mess up. It looks easy, but you just don't want to make this mistake. This is what you're distributing. What do you think would mess people up here if it was just a little different? Something that I could change one thing and it would mess people up if they forgot it.
Change positive to negative.
Yeah, if this was a negative, you'd be distributing the negative 1. This sign goes with this number. This time it's a positive, so if you forgot it, you'd get lucky, it wouldn't matter. Plus 1 distributed out, 1 times x, plus 1 times negative 1. Okay, what kind of equation do we have there? It's going to be a quadratic. Every problem we do is going to turn into a quadratic, and there's going to be 3 possibilities. You're going to get 2 answers. They're either both going to work, one of them will work and the other one won't, or they both don't work. Those are the 3 things that could happen. Okay, so it's a quadratic. We want to get it equal to 0. 2x squared minus 5x minus 3 equals 0. And most of the time, because these problems are already a little longer, I'm going to make it factorable. If it didn't factor, you're going with quadratic formula. That's going to take longer. What's going to be my first term in each set of parentheses? What and
X.
what? Okay, x and 2x. What about my signs? Both positive, both negative, one of each.
Both negative.
If they're both negative, then a negative times a negative would give me a positive right there.
One of each.
One of each. It does matter if you do negative positive or positive negative. I would do negative positive. 2 numbers that multiply to give me 3.
3.
1 and 3, I'll put them in the order that Jared said, but we might have to try 3 and 1. Let's check it. 2x times x is 2x squared. 2x times negative 3, 1 times x. Negative 6 plus 1, negative 5. Perfect. Okay. Now, what value of x would make my first factor 0?
Negative 0.5.
Yep, negative 0.5 or negative 0.5. And what value of x would make my second factor 0? 3, yep. Now, what do I have to do here?
Check.
I got to check them. These might both be correct. One of them might be correct, or they both might be wrong. We don't know. Let's check them. Let's try to plug 3 back into the original problem. So scroll up. Can you plug 3 into the original problem? Right? What's going to happen if I plug in 3? I get 2 times 3 is what? 6 over, what's 3 minus 1? 2, okay. Top is 1. What do you get in the bottom?
0.
Can you do that? No. That answer doesn't work. So 3 is what we call an extraneous answer. Now, could you plug in negative 1/2? Jared, could you plug in negative 1/2?
Yeah.
Yeah. Well, Jacob, can you tell me why negative a half is okay?
For which part?
Well, we want to know why we can plug negative a half in. Why we couldn't plug 3 in. So if you know why we couldn't do 3, then it should tell you why we can do negative a half.
Oh, just makes positive.
What happened, Chris, can you remind me, what happened when I plugged in 3?
At the became 0, the bottom part.
I divided by 0. If I plug in negative a half, will I divide by 0 here? No, that's the answer. If the number you plug in doesn't cause you to divide by 0, you're okay. So the only numbers that would be a problem here are 1 and 3. Negative a half, not a problem. Okay, let's try this one. Okay, how about Brandon? How does this right-hand side factor?
You can pull out.
Yep, I can pull out an x. And now, Kaya, how many different factors do I have in the bottom? 2. What are they? Brandon? No, not 2.
No.
What are my 2 factors here in this problem? Yep.
X and X plus 2.
X and X plus 2. You have an X here, an X plus 2 here. You have both there. What am I going to do with the XX plus 2? Oh, hey, Kara? What am I going to do with that? Yeah, we're going to multiply everything by x plus 2 so that we can get rid of all the fractions. So x plus 2, x plus 2, x plus 2. Elias, what's going to cancel in the first fraction when I do that?
X.
Yep. Gone, gone. What's going to cancel in the second fraction, Chris? X plus 2, x plus 2. And then what about my third fraction? Sam?
Yes. X plus 2.
More than that. Chris?
X and X plus 2.
The x and the x plus 2. Yep. It's going to cancel the whole thing. Okay, so now we've got -6. Now on the left here, we have to FOIL that. Okay, don't forget the distributive. X times x gives me squared. X times 2? 2x. What's 2x minus 3x? Negative x. -3 times +2? -6. That's a simple distributive. Actually, I shouldn't circle it like that. I should circle it like this. +3 times x. Don't forget to use that sign. Okay. Plus 3x. Okay. We're going to add 6, and that's going to cancel it out. Whenever the constant disappears in a quadratic, it makes it a lot easier. So we got x squared plus 2x equals 0. Okay. What can I do here now? Yeah?
Take out an X.
Take out an x. And now, what value would you plug in for x to make this first factor 0? 0. What value would you plug in for x to make the second factor 0? -2. 0 and -2 are my 2 answers. Let's check them. Can you plug 0 into the original problem? No. That would cause you to divide by 0. Can you plug -2 into the original problem? No. So what that means, there's no solution. impossible. You can't solve that one. Any questions on that? Okay. So the homework tonight is on page 244. I'm going to change that a little bit. We're going to do 1 through 9. Odd. 20, you don't have to do 22. 24 should be fine. and 31, those should be fine. Okay, so 1 through 9 odd, 20, 24, 28, 31. Okay, don't forget, I'll be after school today if you need extra help. Otherwise, make sure anything you owe me, it's got to be done by tomorrow. Anything not done tomorrow, end of the term, it's a 0.
Does this count as quarter 2 grid or quarter 1?
This is on term 1.
Last